Recording now. So the first question was with regard to Sigwin and uh, why the installs might not be working properly or not. And I'll have to log into the my machine and kind of show, hopefully, a couple of things. Homestar. Okay. We'll answer the somewhat easier question first. Okay. Sure. It's just me. Oh. So here's the problem also of adjusting the size of your monitor. You don't see all the pieces. Oh, come on. It's just me. Let me. I'll be back. I just need to respond to it. Never eat the computers. What? No. This is ridiculous. I didn't have 30 seconds to. Yeah. Let me see if I can just log into the other account. All right. Unfortunately, it looks like I don't have access to a PC to show to go over the problem. Let me try that again one more time, and then I'll just move on if I can't connect. Connect. Oh, okay, good. All right. So let's view. Enter the full screen. So in terms of starting up Xsigwin, you have to essentially look for it in all programs. And if we're lucky, it should be, oh, there we go. It was Xsigwin. Sigwin-X and Xwin server. If you click on that, what's going to happen is that over the tray over here will show, it should start it up there. Let's see if it, wait for it to start up. Hopefully it won't fail. I haven't tried it on this account, so who knows. Try that again. But this is what you should be able to run. Is this what you're experiencing? That doesn't do anything?
Yeah, I just have some tiny square on my screen after that, and I couldn't do anything.
A tiny square on your screen. Can you elaborate on that symptom?
No.
No? Okay. Uh, somehow it's not starting up on my machine either.
I have something like network credentials expired. I don't know.
Network credentials expired when you do this one, the XWin server. That's unusual. I don't know what's going on there. Let me just show the download with Sigwin X. So Sigwin.
That was a different thing, plug in xwin.sigwin.com or .org.
It's open source, so it may go from different locations, and it'll point you to. Let's do that. RG. It's not private. Yeah, I usually just type Sigwin X and x.sigwin.com. Yeah, that's the one I would use.
I use that one. So I
Use this one. Yep. Okay. So one of the things that when you actually run the install, let's just go through that process. Typically, most of you would have 64-bit machines, so you would click on that. I won't go through the installation because I already have it installed here, but just to show the one option where you want to install everything. So typically, you would run this and say yes, and next, and install from the internet, and then it'll ask you where to put it. That's a good place. That's sufficient also. And you typically will have a direct connection, and you pick out a mirror. So typically I go to some one of the EDUs, the Georgia Tech, doesn't matter whether it's FTP or HTTP, and it will start this process. And one of the things that you want to do is to actually, where it says all here, it says default, and I never really understood what default meant. So what I would typically do is just say okay to this, is make sure that says install rather than just default.
Well, I did it also.
What's that?
I did it also and waited like for 10 hours.
Yes, and the thing is it's going to install a lot of things.
Yes.
So.
But it's not working.
Trust me, yes, this is for some of the folks who tried to install it and it didn't get X. Okay, in your case, you got X on your machine, and why it's not running, I'm not sure. So this is the one probably critical step here is that you want to do an install. Make sure that it actually is not just default, but do an install so that it'll actually install everything. If you want to, you can go through and click the ones that you probably won't need. But I haven't gone through that process of picking stuff out individually, so I'm just going to stop that now and let's see if this thing did anything. It did not do anything. So all programs. Let's try that again. Sigwin. So this one didn't. It did something, but the problem is I don't know what it just did. Let me try running Sigwin, just the terminal. And that's the problem with a lot of some of Windows installations, that everybody has so many different configurations. Okay. Did you, so, did you see what I just did? Okay, so what you try starting up, go under All Programs, go under Cygwin, start up a terminal. And then what I did there is I just typed the command startx, S-T-A-R-T-X. And that started up a Windows server such as this. So this is a little different than probably what some of you have logged in, but you should have the ability to do the same thing that we did in the past, which is like SSH. Let's make this window bigger. From here, you should be able to SSH into armstrong.cis.rt.edu. Okay. Were you successful? No? Something has gone wrong. You're also on a Windows 10. So log in.
I even don't see my mouse working.
Yeah.
I don't know.
Something goes wrong. The problem has occurred. The system can't recover. I could suggest that you buy a Mac, but I won't. I have not tested this on Windows 10, so that's another issue that you might run into. The one thing that I've heard, though, is Windows 10 actually has a Bash shell installed on it. I don't know if that's true or not. That's
Yeah, when I open term,
Yep.
terminal,
it's Bash.
it's Bash. But the problem is I couldn't, if it's not external, I couldn't.
Yes,
open
that's right.
this.
You can't do that. You can't connect to the server.
Yeah.
So I don't know if they actually have an install that actually uses the Xterm protocol. That's something that I haven't played with. I don't have a Windows 10 machine, so I can't really help you with that one. Anyway, so no solution for that one. Other questions before we move forward? I'm trying to think if there's another way of doing this. VNC, you weren't here for the lecture, but you could download Real VNC, start up a VNC server on the machines, and actually interact with that. So just to show you how that would work, you should be able to, can you SSH to the systems?
Yeah.
Okay, so when you SSH into the systems, you can actually let me just make this bigger. Okay. Hopefully you can see that. Maybe it's too big. So I'm going to SSH to and then you can do a VNC server. One thing I didn't go over is geometry. You can actually specify what size this will be. So let's make it a geometry 1024. Let's make it 1440 by 900. So this actually allows you to specify. Actually, let's make this smaller. Okay, 1440, and then you can say colon, pick a number, all right? So I'll pick the number 14, you pick a different number. Oh, I already have one running. Let's make another one, 13. Somebody's got that one picked also. So let's do 12. Oh, somebody's already got all these different servers already running. There we go. So that one's started up. So what you can then do is use something like a VNC server or VNC, real VNC. Let's see if I have that on here. Probably have tight VNC. Yep, tight VNC. Okay. We don't want the service, we actually want the client. Viewer.
Is it okay if it asks for password when I try to access the server?
You should specify a password that's different from your regular login. Okay. So
My regular password on my regular.
just VNC password is different from your login. So what you want to do is you just want to specify some password that just allows people to actually see that particular window. So let's. So in this case, I said Armstrong, and then it was :54. Okay. And that's what you should get. Okay. So you basically have a virtual window on Armstrong.
So the program was
Real VNC or Tight VNC. Okay, so you can download that program. So that gives you an ability to at least access the Unix system and not necessarily have X Windows running. What's actually happening is X Windows is running over there on a virtual desktop, and that virtual desktop is being transferred. You know, the image of that virtual desktop is being transferred to you, almost in real time. So everything's being redrawn out on your on the client on the server side, and real VNC is basically transferring that information to you, but you have the ability to actually control this. Okay? So this is actually different from X Windows running on your machine and talking to the server. What in this situation, X Windows is running on the server in a virtual desktop in the server, and the image of that server is being transferred to your machine locally to VNC.
How to close this session if I want?
We want to do VNC server minus kill, colon, whatever number you picked. Okay.
And if I was on Armstrong, it will be Armstrong.
It'll be Armstrong, correct. It's not. It'll be specific to a specific machine, right? So this will allow you to bypass. In fact, allow you to bypass using X Windows in this situation. So the issue with this is, like I mentioned in last class, is that it's not a very the traffic is not secure. The server has to actually be has to have some encryption, and the way the system works is that you actually have to pay for that encryption to occur. You know, it's the business. This is the business model of the people who wrote real VNC and tight VNC. So, okay. Let's see, other questions that people may have had. Yes.
So what was the character between the two numbers? Geometry.
Oh, that's the width and height.
Yeah, I mean, is it x with x?
Uh, samples, width and height.
Yeah,
So
what's the character between the times?
the
Times it doesn't work.
times.
The command. I mean.
Let's see. The command I typed in there was. Let me check.
For geometry, 440, and then that's x.
Yep.
Small x.
Small x.
I guess
What did
just command.
what error did you get?
Small x.
So what was so you type VNC server
Yeah, VNC server.
minus geometry, 1440 x 900 colon 14 or colon whatever.
Yeah. And it shows that this server is invalid. This command is invalid.
Let me see what you got there. Oh, there's a space between 1440 x 900 and the colon 14. You ran it together as one.
Oh yeah, I got it.
Okay.
So it's
Yep.
perfect.
Yep. So, yeah, the problem is that the spaces don't have there's not an easy way to show spaces. Okay. All right. So, let's go over what do I have on my list of things to talk about. Let's talk about regular expressions. So some of you may be familiar with regular expressions, maybe not, but let's go ahead and do that. So I'll go huge on this. I'm on Armstrong. And is that big enough for you people to see, or should I find a bigger, a little bit bigger? So I guess I'll move on to this. I don't really need to play with X windows. An X Windows session, so we'll deal with this one. So what I'm going to do now is I'm going to CD into that area where, so CD tilde is my home directory. I'm going to images, MISC, okay. And that's all the files. Now, some of you are actually using regular expressions. Some of you may actually have seen the following, where you would say ls star.tiff, okay, which means just show me everything that has the extension tiff on it, so ls star.tiff. But there actually are a lot of variations associated with regular expressions, and we'll just go over a couple of them. So if I wanted to just choose all the cases that start with 4 and 5 characters, or 4 and 5 in terms of the actual characters. That's the way I would do that. What the brackets basically say is that I want to choose anything that starts with a 4 or a 5. I can elaborate on that by basically saying 4, 5, and E, for instance. What that means is that I'm only going to find anything that starts with a 4, 5, E, star. So as you can see, you can specify a whole bunch of different options here. In fact, one of the options that you might see that people use is 0-9, which says, give me everything that starts with a number. The other one is to basically say A to Z, which tells, give me everything that starts with a letter. So that's a form of a regular expression. If I wanted to just substitute a single character, for instance, so if I wanted to say, give me everything, 4 dot, and then any character, okay. The period here, the question mark here is one of those meta characters, which has special meaning. So you have to be very careful when you're using meta characters, particularly if you're a new Unix user, because you may think, oh, that's an actual character. It's not. It actually has some meaning to it. So the question mark here says match any character at this location. Just a single character. If I put star there, it would say match anything. So you can also specify matches by giving it giving it a range. So I would say something like ls, or not range, but instances. You could say Elaine, comma, and then house, star.tiff. And what it'll do is it'll actually use each of those instances and try to substitute it in terms of those searches. One of the things that actually is kind of weird here is that you actually see there, it's kind of hard to see, is there's a star.pnm, which I inadvertently created. And this is actually something that the people used to do for people who don't log themselves out. What people would do is they would play a joke by creating a file called star there. And guess what the Unix person will try to do? They would try to remove that. They would say rm star and find themselves actually deleting their entire directory. So it's a bad joke, but it does happen. So how do you actually you see that star.pnm? How do we actually get rid of that? Well, what you actually, if you recall, we said that you can put quotes where there are, so that there is no substitution. Now, if by putting these single quotes there, you're basically saying take the star literally. In other words, don't do what's known as an expansion. You know, don't interpret that star as a meta character. So when I do that, you'll see that I actually did get rid of that. Right. So the other way to escape certain characters, so let's actually, I'll create another file with the meta characters in it. I say touch junk. You can actually put a prepend it with a forward slash and then say dot dat. Okay. So you'll see that there's actually one file there with junk question mark dot dat. Okay. If I didn't know anything about regular expressions, I would be saying something like rm junk dot dat. It might actually work. Yeah, that one works, but that works because it says match a character and the question mark happens to be a character. So that was a bad example. But be aware that sometimes you inadvertently put a meta character in your files. Now, this regular expressions, I'm just touching on it very, very superficially, but it's a very powerful way of actually finding patterns in your in text files. Okay, a couple of the patterns that you might want to look for is I want to look for everything that's all numbers but not letters, or everything that's all letters but not numbers. That's actually useful for trying to get rid of headers, for instance. If you have a set of text files where all you have are numbers with some alphanumerics for your headers, you can easily use that pattern to bypass those certain values. So that's something that you can try to use that for. So that's just the way patterns work. I'm trying to think if I have a text file that we could work with, but we'll see patterns again when we actually do a little more of the awk process. Okay. Any questions about regular expressions? Yes.
If you say remove head and then with the use all the text from the top of the file, we have text and numbers on the bottom. You say remove.
You could do it that way too. There's a lot of ways of doing things. The head command may be another way of doing that. The other method I was thinking about is that sometimes you may not necessarily know how many lines you have in terms of the header, but you can say in some applications such as awk, say that if it contains a character, if it contains an alphanumeric character, ignore it. All right. So just as an example, let's see if this is a good example. Let's actually do this. ls myfiles.txt. Okay. So this is just a file, and we have a mixture of numbers and letters. So in VI, I can actually go through and just find all the instances of .tiff and just get rid of them. So as you can see, I just did that. Right. So we have just a bunch of numbers and letters. Now, if I wanted to oops. That didn't work. 009, something like that. This was a bad example. I was just trying to see if so this just prints everything. I was going to do a oh, I know what it is. So what you'll notice here is that it only selected the files that had numbers in it. Okay, so let's prove that. If I remove this particular pattern and we look at the count, WC minus L will tell us the number of entries. There's 53. So if I just say WC minus L myfiles.txt, it should have 53. Now when we did this command, okay, let's see how many entries are there. 44. So what we did here is we removed any of those entries that actually had numbers in it. Okay. You can actually ask it to do the difference by putting a special character, and I'm going to not remember this, but I'll try. I think it's a dash. Nope. It's that, or is it not? No, I don't remember. But there is a way of actually let's go the other way and just say A all the way to Z. So does that, it's a little bit off, but so let's actually look at that output. So what this says is just give me everything that has a character, characters in it. Okay. It's kind of a bad example, but it shows you the power of using patterns. So if you think that you have a pattern with regard to not just your text files, but the data that you're working with, it is conceivable that you can come up with a one-line filter that will give you the appropriate set of text files that you're trying to work with. The other thing that what you need to keep in mind also with regards to file naming convention is that if you're using numbers, try to pad it with zeros, because if you don't, you get a different sorting process. The way to think about that is the following, where if I say sequence is a kind of allows you to just create a set of numbers. So let's do 1 through 100, and just 10 is fine. Oops. How will this sort? If I pass this to sort, how will it? What will the order be? That's right. It's not what you expect. Okay. Which is very annoying when you're dealing with file names, because you're saying it's like, oh, I want to go from 1 to 2 to 3 to 4 to 5, and if you don't realize that, when you deal with all your files, you'll see 1 and then 10 and then 2. That's because what the file names are sorted in lexical order. In other words, in alphabetical order. So how do you go about that? Well, what you can actually do is you can actually pad it. Okay, so one way of padding it is in sequences, is to do the following, where it would automatically add a 0 in the sequence of that. So in terms of file names, we haven't really, what you can do in this situation is create your own file names by putting the sequence. So I can apply this to A equals SEQ minus W 1 comma 10, okay. Echo $A, and then you can say for I in $A, do echo file name, then $I. Okay. So what you've done there is you've created a set of file names that that is probably more of what you want to use, rather than applying a sequence of 1, 2, single digits. So one of the things that I always recommend people to do is, if you're going to create a sequence of file names, to try to pad it based on the largest number that you have. Okay? Because it'll make your life a lot easier when you're actually trying to sort things out, when you're trying to pull information, okay, from your different data files. By knowing that you're in a sorted order that you expect, you will be pulling your data in appropriately. Okay.
So when I try to like assign the command to array like that, if I do that, then it just comes up with
Well, so you try to do A equals backslash, or not the quote there is sorry, the quote there should be the different quote. It should be the
I couldn't see it.
yeah, I know. I could make it bigger, but I think it's because of the background. Let me see if I could. That's why I don't like. I can't figure out how to make the changes.
What's the quote?
It's the other quote. It's the backtick quote.
So if you got A equals LS, it's got the quotes on there too then. A equals LS.
It depends if you want to use ls as a value. So let's do that. If I said A equals, if I did ls, just ls right here, and I said echo $A, it'll just give me ls. Okay. But if I say A equals backtick ls, backtick, and I say echo $A, then it's all the
You did this the other day. I just typed in A equals LS and I couldn't get anything. I didn't write everything down correctly.
That's fine, and that's why I record this, because there's a lot of material that I talk about. I mean, you're getting, I don't know how many decades of Unix experience here that I'm dumping at you as quickly as my brain can come up with the bad examples. But it may not seem useful at this point. But I'm again hoping that later down the road you'll say, oh yeah, I've seen this before, and click something in your head that says, oh yeah, I want to go back and review that, because file naming may seem like a trivial thing, but it becomes non-trivial when you're dealing with like thousands of files. It becomes very, very painful, and how to deal with that becomes a major issue. So. Yeah, if you're having issues, just let me know, and I can walk over and go over that. It's a lot of the things I show you are very detail oriented, and then one misstep, and you're like, you're oh, I can't follow. So, is that
Still not working.
still not working? Okay, let's take a quick look. Are you using? So the question is, are you using Bash or are you using Are you using Bash? You are on Bash. Okay. So sequence may not be in. Oh no, you were able to do that. Yeah. Okay. Yeah, that one. So they return. Oh no! Don't put any spaces between your equals. So if you look at the, I think I don't put any spaces. In Bash, sometimes the spaces can cause issues. Still. Yes. Okay. Yep. Sometimes spaces are not critical, but for some reason on the shell, it is critical. It's not just Bash. C shell also has issues with spaces, and that's something that I never really sorted out. So that's good. We're reviewing something that we went over, and you guys are playing around with it and seeing that. So. Let's see, what else did I have on my list? I had regular expressions. Again, if, regular expressions. Just be aware that they exist. One of the unfortunate situations with regular expressions is that they are not universal throughout all the different applications. In other words, regular expressions in VI, in awk, and in Perl and other languages are different. So how you specify certain patterns can be not intuitive because you're familiar with another form. The easiest one that I showed you here is on the shell itself. So on the Bash shell, but keep in mind that different applications will have different patterns in terms of regular expression, and we'll see that when we actually work with SED, Stream Editor, which I'll show you how that works and how some of the patterns, albeit powerful, can be a little annoying to work with. Okay.
If you want to do something like in a loop, there's like multiple commands. You could write like a shell file or whatever it's called, a .sh file.
So.
Like in something I was trying to do, I was trying to loop through something, make a directory based on the file name, and then run a command, and then do that in a loop.
Yep, you can do that. So as an example here, so let's say, in fact, those are the kinds of questions that I like hearing, because you'll say, okay, so these are all the files without the .tiff extension. And just for the sake of argument, let's actually do this in user temp so I don't mess up my files. I'll copy my files.txt to user temp. And then I'm going to let me go to user temp. Okay. And then I'm going to create a directory called, I don't know, junk test. I'm going to move that my files to junk test, right? CD junk test. It's actually a very good example. So let's just say, for the sake of argument, I want to take all the files in here, which are my directory names, and I want to create directories out of all of them. Okay. There's several ways of doing that, but we'll just do it to illustrate a couple of things. So we can do the following. We can say A equals cat myfiles.txt. Okay. If we say echo $A, we have all those directory We have all those file names. Now what I can do is I can say for I in $A, do mkdir $I, and you can say echo I am processing $I. Okay. Done. Okay. Oops, because I missed. Anybody know what was wrong? Yep, I forgot the second quote. So, right there. All right, so if you look at this, these are all directories. Okay, how do we know that? If you do an ls minus L, you'll see in the permissions the D option or the D character that tells me that I have a directory in each one of these. Okay. So what you just did is you created a whole bunch of directories.
Oh,
All right. Was that similar to what you were thinking of doing?
Yeah, I was using a program where I was splitting layer tiles, and for each tile, I put those tiles into a folder based off the file
Yep,
name.
the file names, yeah. So this is what you would do. What typically do, the way I typically work with something like this is I usually start up with a file that contains all the file names so that I can actually pull that in and then go through and process each one. Now, because you have directories now, you can actually start copying files into each one of these. So
Yeah, so like the way I was doing it was for each file, I wanted to make the directory and then specify the output directory for the files the program was making to be that directory.
Yep. So that's the way of doing that. You can also start populating things. So in this case, let's start all over. Let's do rmdir. So that's to remove a directory, and let's move my files out of here because I'm just about to delete. I'm going to move it up one directory. Then I can do rmdir star, and that removes everything. Okay. If those files contain something, it won't let you delete the directories. Okay. What you have to do is type the following commands: rm minus rf star, which is probably one of the most dangerous commands that you can ever invoke. It's just delete everything. It just says delete everything and don't tell me about it. That's what the F stands for. It's like force the deletion. So whenever you give this command, always type a pwd so you know where you are. Okay. Again, this is one of the most dangerous commands you can give on a Unix system. Okay. Rm minus rf star. Because what this will do is we'll just start from wherever you are and go down and just start trashing everything. So always know where you are when you give this type of command. Okay. So let's copy my files. Back here. Now suppose, just for the sake of argument, we have input.txt here. Insert 3.14. And you wanted to copy that particular program or that particular file name from into each of those directories that we just talked about, right? Well, there are several ways of doing that. Okay. You could say for I in $A, do make the directory. Okay. And then you can either copy it from the current location, or what you can do is you can say push d $I, In other words, you go into that directory, and then you copy that file that's above you. So let's call that input.txt. Okay, and then you want to pop back out. Okay. So let's go over this command. You go through each directory, you create it, you go into it, and then you copy the input file from above. Because what you've done is you've moved yourself into that directory, and now you're going to copy that information back into the current working directory. So I said copy input.txt, but I didn't tell it where to put it, so I have to put period here, which tells me put it wherever I'm currently sitting. And when we actually do that, all right, oops. Why didn't it work? Because I didn't have an input.txt. Yes, I didn't. So I thought I created that. Okay, it's there now. So sometimes what you do is you can do a make dir, and if you have that's just to create one directory. If you have a set of directories that you need to make, several layers deep, you can put the -p option. The -p option will basically allow you to create a string of directories, okay, at different levels. So let's actually see if this works. It already exists, all right. Oh, but it did actually copy some of the input.txt and some of those files. So actually, let me clean that up again. Oh, wait a minute. Oh, I did have that. Oh, I went to the wrong file, wrong directory. All right, so there is input.txt in each one of those. It did work. So you can think of actually copying a whole bunch of files into a directory using this shell script. All right. Any questions about that? So let's talk now about another facility. So one of the things that you can actually think of doing is that you're going to run a process on like 1,000 images, for instance. What I usually tell people to do is to create like 1,000 directories that hold each process. Okay, the reason for that is that it becomes a little easier to deal in in each of those situations. So for instance, if you want to convolve an image, for instance, you would create a tree of directories that allow you to treat each process separately. In doing that, the naming conventions that you have can be simplified. You can actually have your input.txt and have something like answer.txt for each of those directories, and never have to worry about what kind of file name you have to remember, okay? Because its sequence in a directory tree structure will always be the same. And also what this allows you to do is it allows you to actually distribute this set of runs on different, on a cluster, for instance, because that each CPU will basically just go to each of those directories and run it. Okay. And the other thing that also is that would be helpful in this situation is what's known as a makefile. Okay. If you don't use a makefile for long running jobs, it may be something that you want to consider, because if you just write a script and you tell it to process a whole bunch of directories, what happens when that process, which takes a week, dies in the middle of that process? Okay. How do you know where to restart your program? Okay. How can you tell it where to restart? Okay. If you had used makefiles within each of those directories, it is possible for you to bypass having to process results that you already have. So let's think of an let's come up with, first of all, let's talk about what a makefile is. So a makefile is simply a file that tells you how certain things are created. So in this case, let's create a file. Let's create a makefile and say answer.txt. Okay, I want to create a file called answer.txt. It is dependent on input.txt. So this is how a makefile works. A makefile basically says, I have a file that's dependent on another file, and in order for you to create that file, this is the command for you to do that. Okay. So let's just do something silly here and say echo 2 + 2 BC minus L. And we saw that before. Right. So let's look at what that makefile looks like again. So it just simply says, in order for me to create input.txt, I want to do the following. Right. So is there an answer.txt? There shouldn't be. Right. Is there an input.txt? There is. We have that. Now if I say make, it'll just go off and go to that makefile and just do it. It knows what to do. This is actually very useful because now you can have a very, very complex command and you can tell people, oh, just type make, and it will actually document for you what are the steps that needs to be done and what are the dependencies that needs to occur in order for something to get created. Okay, so now if I say ls answer.txt, oops, did it do it? Oh, it was a bad makefile. Okay, what's wrong? What's wrong with this makefile? It has an echo, but I never told it to create the file. So actually, that was a, yeah, I never told it to create the file. So to fix this, hold on. What the? Oh, something is amiss here. Yeah, let me. It's the color of the. Yeah, it's the color. I should have stuck with the white color. Let me see if I could. Options. Foreground, we want to be. Sorry. Try not to do things. Why did that get changed? This is all messed up. Let me go back to the here. Can't make it too big. It's already, but hopefully this is a little easier to see. Okay. Is it hard to see? All right. Let me just do this then. Actually, let me just get out of remote desktop. I wasn't thinking. C. Right. Okay. Big enough, right? So. Answer.txt is dependent on input.txt, and I would say echo 2 plus 2 just as a test. Pipe that to BC minus L and redirect the answer to answer.txt. All right. So if I type make, what it'll do is actually run that command, but when I type make again, it'll say it's up to date. In other words, it's not going to redo that file, because what it realizes is that answer is actually newer than input.txt. Okay. In other words, I've already gone through that process. I don't need to make that command again. So whenever you type make, it says, I don't need to make this. It's already been updated. However, if I say vi input.txt and I make some edit to it, I put something like that kind of edit, and I type make, it'll realize that input has changed because the answer is dependent on the input, and it knows that it's changed. It'll say, oh, I got to update this. So it'll go through and execute the next line in order to update that. Now in this case, I just used a bogus command here, but what I want to do is I want to illustrate the fact that if you have some input file that gets changed, then you have to go in and update that. Also, if answer doesn't exist, that means that you probably haven't done that process in that particular directory, so that when you actually try to rerun something that actually failed in the middle of a bunch of your directories, it'll know where to start. Okay, the make file will sort of say, oh, this has already been done. I'm going to move on to the next directory and execute the make command, and so on and so forth and so on. Okay, and that's one of the reasons why I also showed you that you want to be able to copy files from the above to your local directories. That's actually one way of doing it. We'll also talk about how you would have just a single file that you can edit in order for all the other directories to be able to use that. But this is just what a make file does. Sometimes, actually, make files are used by programmers to compile programs, but some of the make files that they actually create are very, very terse, and they never actually express it in this manner. So most people who look at make files, they get like scared off and say, oh, I don't know what the heck that is. But in its basic form, a make file is simply a file, what it's dependent on, and what is the command in order for you to create that file. Okay. So just to illustrate also, is that you can actually make the make file be dependent on other things. So input2.txt, for instance, right? If you try to do this and type make, it'll say, I don't know how to make input2.txt. Okay, in order for me to work, I need to know how that's created. So what you can do in make files is the following. You can say, well, in order for you to make input2.txt, I can make another dependency that says input2.txt is dependent on input3.txt. Right? And how do I create input2.txt? Well, you might do something like echo hello to input2.txt, right? Or something like that. Or let's actually do this. Let's do cat. .txt. And likewise, input3.txt might have a dependency, right? You might have that depend on something else. In this case, we'll just ignore that. You can put so as with many files in Unix, a pound sign will allow you to comment things out. So let's actually execute this. Let's say up, no rule to make input3.txt. I can say touch input3.txt. What the touch command does is it just creates a blank file. If that file already exists, what it'll do is it'll update the modification time. So this is actually a way for you to force make to run something. So now if I say make, it knew that it had to create the input2.txt, and it knew that input2.txt was needed. So now you have an answer.txt.
I have a problem on creating the make.
Okay.
It says, when I type make, it says no target specified in my make file.
Okay. So here's a. Let me ask you this, and hopefully it is the problem that most people run into. Did you use tabs or did you use spaces?
Spaces.
Ah. Yes.
For where? Make
For
tab, where should I put it?
the tabs are for this right here.
Oh.
And that is a major problem with makefiles. Unfortunately, that thing's never been fixed, but that is a common problem. It has to be a tab, okay? And unfortunately, there's no way for you to distinguish between a tab and a space, which actually brings back yet another command that I wanted to talk to about later, but we'll talk about it now, and that is OD. Okay. OD is probably one of the most powerful commands in Unix because what it does is it takes a file and displays to you a file in its rawest form. So this is a text file, so we can do the following, -bc, make file, and typically OD will spew out a whole bunch of information at you, so it's always good to pipe it through more so that you can sort of page through the information. And if we hit return here, what it's doing is it's giving you the octal values of each of those characters in that file, right? So if you actually go back and look at the ASCII table, you will see answer, each of those characters represent a particular answer. So in this case, we can see where space is, as indicated by 040, right? But when we actually go to the line that actually has the command, you'll notice that there is a /t right before echo, as indicated by 011. Okay. This is how you actually determine whether or not you've got spaces, or this is one way for you to determine whether you have spaces or tabs in your text file. Okay, is to use the OD command. Okay. In this case, the options I used are B, C, which means give me binary. So I can act, if I just said OD minus B, all you will get is the ASCII values, octal ASCII values, not decimal. Keep that in mind. These are all an octal. Okay. If I just give the C command, it'll just give me the characters and how they're spaced out, but doesn't tell you what the values are. So the combination of B, C will give you both the characters and the associated ASCII values. Right? And this tells you, and this command is the one that I always use, is the BC, and you can see that you've got a tab character as indicated by a /T there. Okay. And that has an ASCII value of 0, octal value of 0, 1, 1. Okay. Yes?
When I type make, it always shows the answer case.
Oh, in when you type make, up to date, because it already created it.
I think I created it in calculate. So it means it's done.
It's done. Yes, it's done.
I still have the same problem.
Okay, let's take a look.
The moment I did.
Okay, so we're sure that that's not a we're sure that that's going to OD minus BC and see if we get something similar in this case. Ah, okay. Go ahead. Okay. .txt. You made it .txt, and go ahead. Everything's correct in your case. The issue is that you gave it the .txt extension. Unix will basically look for two default make files. One is makefile, and the other one is capital M A K E F I L E. You can use other names, but what you have to do is you have to say make minus F, and in your case, makefile.txt. Okay. You can make files. There are the two default names are makefile, all lowercase, and then capital M makefile. Okay. Did it work? Yes. Boy, you're coming up with all the good problems so far. No, that's good. That's how you actually, it's like you now there's two mistakes that you won't you won't have to make anymore. So that's the essence of the makefile. Now think about, we made very simple examples here, but think about each of those as being a result image and an input image. And then you have a command there that does the process of that image. All right. You can use the makefile to control that process. And as you've seen also in this particular makefile, is that you can make dependencies on different parts of your image processing chain. Okay. You can say, I want to run this part first. And then once I've run this part, I want to run this process on it. And it's actually a very good way of checking things as you move along. Okay. One of the problems that, not problems, but one of the shortcuts that most people try to do is they'll try to make a very complex image processing chain and not necessarily look at where it is that a problem may have occurred. And in order for you to do that, you may have to actually output temporary files to sort of see that the convolution worked fine here, looks good. The edge detection looks like it's working. But if you just combine all that and then come up with a final answer, it's sometimes hard to actually determine where in that processing chain might have gone wrong. So a makefile is sort of a good way also to spew out temporary files and still be able to move forward without having to do any reprocessing. So any questions about that? Well, hopefully next week we can try to combine all the things that I'm talking about into a cohesive runs on Slurm. I will forward you and I haven't heard from the research computing guys whether the machines are available. Do you know if they're available? They're available? Okay. So I'll send out a link to you guys to actually get an account there, and we'll go through some simple examples so you can actually get comfortable with actually running things on the Slurm cluster using both makefiles and some of the processing that I've talked about. Any questions? We still have half an hour. I can continue and keep going. You're probably. Okay, so let's look at your. That's right. There's no input to .txt. So you either have to create one, or you have to. So you can, if you say touch input to .txt, then it should run. Yep. So that cascade of files is actually pretty useful. So. I'm running out of gas, but I'm willing to go through one more example. Start up Xquartz. Now, what I'm going to do is I'm going to actually use NV as a way to start up, create some test images, and to illustrate a format probably one of the simplest formats, and unfortunately, or fortunately, is a de facto standard in remote sensing, because there really isn't a good way of, or good file format that people can use. Most of the images that we've looked at are basically red, green, and blue images, but in remote sensing, you can have images that have many, many bands, and there are no standards for multi-band image formats short of the NV format, and we'll actually create an NV test image just so you understand what that format looks like. Okay, and we'll go through several of these types of images. And here you can actually create a test data and create a file. So I'll go through a couple of examples. So let's create, and to illustrate, to sort of drive home how data type is important. So I'm going to put the value 3.14 in here, and I'm going to create an image that is super tiny. I'll make it 1 by 1. So it's just a single value. Hopefully that should work. And we'll call it byte image.img. Okay. There it is. We won't try to look at it because it's not very helpful. But let's stop here.
So this is telling me that this image is 1 byte long, and we actually have a header to tell us that. So that byte.img is strictly image data. What you have is an accompanying header file that describes that. So you can think of the header file, the HDR file, as being metadata, because it'll tell you who created that image, the number of pixels, the number of samples, number of lines, number of bands. Okay. It also tells you the data type, which is 1, which is a code that says this is a byte image. And the interleaving, we talked about that, the sensor and byte order, and we'll talk about, we'll go over what some of these mean. But for now, let's actually look at this file. Okay, so we have the OD command to actually interrogate that. OD minus B, and then byte image.img. That's exactly what we typed in. We typed in the number 3 as a single pixel into that file, right? So that's not too weird. Now let's create another image. Let's call this one generate test data. Put in the value. Now, well, actually, there is something weird here. I put 3.14 as my value, but it came out as 3. The reason being, a byte is an integer, or it can only take is an integer value, so it had to truncate that 3.14 into just that value 3. Okay, because it can't represent that. Let's make it again, same type of image, 1. This time, however, let's move it into an integer form. Okay, and let's save that out as integer.img. Okay, and let's look at that again. Let's look at that now. This time it's 2 bytes long, right? But let's look at the header associated with that. We'll see that there are differences, okay? If you want to actually compare 2 files, you can use the diff command. So we can compare byte image.img.hdr and integer.img.hdr, and these are the differences that we see. Okay. We see that from the header that we have differences in terms of creation time and also in terms of data type. Now let's actually do an OD minus B on integer.img, and there's something weird going on here because we're interpreting it as a 2 bytes of data, right? And one thing that I want you to notice is that 2 bytes of data is going in a weird order. Because we know this is actual integer, what you actually have to do is you have to give the, I forget what the option is, man, OD. I think it's the minus D. Integer.img. In other words, this particular pixel is being represented by 2 bytes of data. And that's important because whenever you're outputting data that's more than a single byte, you have to take into account what is known as the endian of that pixel. Okay. Machines, unfortunately or fortunately, because of architecture, have what is known as an endian characteristic. There is what's known as a big endian machine and a little endian machine. Okay. Most machines these days, I believe, are little endian if you're Intel. Okay. There are some machines that can actually do either. And what does that mean? It simply means that when these bytes are written out, it's the order in which they're written out. Little endian means the least significant byte gets written out first, which is why you see the 003 first, as opposed to 000 and then 003. That's a very important thing to consider and to understand, because if you're getting a data from a machine that's little endian and you're on a big endian machine, the values that you'll be interpreting are different. So I think if I say OD minus D here, and I say endian equals big, that is the number I would interpret. If I say endian equals little, that's the correct interpretation. If we look at the header files, that's what this byte order means. All right. Yes?
I didn't understand that. So you're trying to convert a big and a little, this would be a little Indian machine right here.
That'll be a little endian machine, and I'm trying to do is I'm trying with the when I said what did I have here? I'm trying to interpret that. I'm trying to interpret it as if it came from a big endian machine.
So next week, if we go on a bigger machine, then
No.
we have to switch over things.
Oh, it has nothing to do with the size of the machine. This is an architecture consideration. So back a while back, there used to be Motorola CPUs and Intel CPUs. Motorolas were known as big endian machines. In other words, when they write things out, they would write the most significant bytes,
Oh.
okay, first. Okay. So in this case, what you're doing is you're just swapping the bytes. Okay. There is that ordering. You know, how do you output the data? Do you output the most significant byte first or the least significant byte?
So you have to set up your machine then differently if you're going to the machine then. Are you going to have to reformat your data set then either?
You may have to, depends on, so if, let's say, a situation may occur where somebody has a new sensor and they happen to use a particular computer that is big endian, okay, and they're dealing with multi-byte data, okay, that computer, by its nature of design, will write out the most significant byte first and then the least significant byte. And you get that data in that form. Okay, let's say that you're on a machine now that's little endian. You know, it's assuming that what came in first is the least significant byte, and then work on that assumption. So what you need to do is you need to understand what kind of machine that data was created on.
Yeah, that's what I was wondering. Do you have to convert that over then somehow before you work on your data?
That's right, because if you look at the header files here, that's why you have this option. That's why they give this byte order. That's why on this particular, if you didn't have this header file, you'd be totally like up the creek because you would not have known how this file was created. Right? In this case, NV actually writes out that information regarding the byte order.
so that you at least have an understanding of how that was created. Okay, so in fact, that's one of the options. You can say, you know, are you an Intel machine? And it's an unfortunate situation, but it is something that you have to watch out for, particularly if you're working with engineers who are working on a particular system and they output the data in bytes, in byte form, in non-human readable form. You have to be aware of that, particularly if you're dealing with multi-byte data. Most of us didn't care about that because most of the images that we've been working with are single bytes. Okay, there is no swapping a single byte. Okay, it's always 0 to 255. However, as you create machines or you create sensors that require more quantization information, okay, you have to take that into consideration. You know, anything more than 8 bits of data will require you to understand whether it's a little endian or a big endian output or data. So very critical. I think what I tell people is that if you start looking at images and they look absolutely weird and the statistics make absolutely no sense, then you've probably run into a big endian, little endian. And that's why it's always important to know how many bits of data does your sensor actually use. Okay. By knowing the number of bits, you know what the maximum value is. Okay. And if you start exceeding that maximum value, my first instinct would be to say, well, did we swap the bytes? Because if that's the case, you shouldn't be getting those values that are like extremely high when your sensor is not built to generate those kinds of values. So, all right. Any questions with that? Let me just let's go through a couple more iterations here just to drive the point home. So let's create another data set, generate test data, 3.14 again, one line, and this time I'm going to make it a long int. Okay, and there's also unsigned. There's also the concept of signed and unsigned. I won't go into that today, but let's just make it a long integer. Let's call this long.img. Let's get out of here. So long.img. And we notice here that it's 4 bytes long. Okay. If I did an OD minus B on this, okay, you'll notice that 3 is the first one, 0, 0, 0. So again, the least significant byte is being written out first. In order to look at this appropriately, you would say OD minus, I think it's L, .img. So what it's doing is it's taking all those 3 bytes and saying, I am a single pixel value that can range from anywhere from 0 to 2 to the 32 minus 1. And finally, this one is something that's kind of hard to actually take into swallow because there's a whole bunch of calculations, is to write it out as a floating point. Float.img. So if I do an OD minus B on float.img, you're like, you look at those numbers like, it doesn't look like pi to me. But if you actually interpret it, give the proper option, it does know that it's floating point byte. Okay, there's an actual IEEE spec on how you actually take all that bit pattern and put it into a floating point value. You know, it's non-trivial. I went through it once just to convince myself that it does work, and it is it's like you have to do like a binary decimal, not binary fractions to get it to work properly. But it is possible. So sometimes if you got this image and you did an OD on it and you're not interpreting it with the proper switches, you can see that 303, 365, 110, 100 looks nothing like 3.14. But because we know that that's how we created it, we can use the proper switch to actually interpret that properly. So it's very crucial that you know what data type your image comes in, and often in cases like this, you want to use some sort of header information to do that. The NV image header is kind of nice in that you can actually edit that for better or for worse. But let's look at the more float.img.hdr. Okay, and again, it shows you some sample of lines, and the only thing that changed there is data type, okay, which is they've specified as a floating point. There's also other data types such as doubles and complex numbers, and that becomes a little bit more of a mess, but you have to kind of know that before you can actually start messing around with that. And as you can see, even though we use or have similar numbers for all of them, each of them have different sizes. Right? The byte image is only 1. The float has 4 bytes. Integer has 2, and the long has 4 bytes. So things to consider when you're actually writing out full images. Okay, and that's why a lot of people will defer to using integers to represent their data. Okay, because if you try to write out a floating point data set, that may take up 4 bytes of information or 8 bytes per pixel. And then if you multiply that by the number of bands that you have, that becomes a very, very big data set. So sometimes what you get is an integer representation of some quantity, and that requires you to do some sort of calibration in order to get that integer value into some physical quantity. Okay, there's always a calibration associated with that. 0 to 255 for pictures have very little meaning in terms of physical quantities. Okay, that's what unfortunately some people sort of think that that's how you want to work with these sets of data. And for some situations, for visual inspection, that's fine. But if you're doing some quantitative analysis, 0 to 255 really tells you nothing, okay, other than some spatial pattern that's correlated to some physical quantity. Okay, I think I've run out of gas, but I'll post this all up. And please bring questions next week. Think of something that you want to address so that we can try to hone in on certain skills. I think I've given you a smattering of a lot of pieces that will make things dangerous, and hopefully you won't delete your account. So, they do make backups, but sometimes, depending on when you delete your account, you may lose work. Have a good weekend, and we'll see you next week. If I don't get it to you today or tomorrow, I will send you the link that will allow you to set up an account over in the research cluster. And I'm actually trying to get Paul to come in to give you a spiel, but if he's busy, I'll take over. Okay? Thanks.